All right, welcome back from break, scholars. Welcome back to pre-calculus. Like I said in the agenda for today, we're going to be talking a lot about trigonometry, shapes, triangles, you name it, for a big majority of the class. And of course, to understand those, we need to have a good handle on angles. So this might be a relaxing lesson to kind of move through, but I'm going to tell you a bit about a different angle measure which we may have never heard of before, and a couple other things that are a little more formal, but as long as you are using your own knowledge on angles, it should be pretty easy. So let's go ahead and get started. So, basics of angles, pre-calculus. Here are our objectives today. Okay, so I'm going to be going through all of these, and we'll see this in the slides too. But hopefully you can take a look at these and figure it out from the notes. But we're going to answer those in the notes. Let's go. Okay, so first things first, what is an angle? Very simple. Okay. An angle is formed by two rays. Remember from geometry, a ray is basically a point and a line. Okay, but it only goes in one direction. But in this case, it's two rays that have a common endpoint or vertex. That's this guy. One ray is called the initial side, initial, and the other side is the terminal side. Okay. So a terminal angle can lie in any quadrant on the x-axis or y-axis, which I'm going to show you in the next slide. Okay. But this is like the terminology. These are not so important to know. It's just nice to have this formally put, since we do want to try to be rigorous in our work here. So let's go ahead and move to the next slide here. Let me erase my stuff here as well. Okay. So next part is an angle. We call angles in the plane standard position if the vertex is at the center, okay, of the plane, so that'd be right here. Okay. And the initial side, very important, initial side lies along the horizontal x-axis. And I should also note this is a positive as well. Horizontal positive x-axis. So let me change my color here. All right. So in the red, I'm going to use a different kind of thing here as well. So in the red, okay, this would be my initial side. Okay, initial side of my angle. So whatever my angle is, okay, I'm going to have another side, the terminal side, right? I'm going to keep my red. Let's just say right here. Okay. This is your terminal side. Okay. We would call this example that I just drew out for us. Sorry for my terrible handwriting. I haven't done this in a while, so hopefully I'll get better with it as it goes along. But we would call this angle, okay, an angle in standard position. Standard position. Okay. I see it's centered at the center of the graph, and the initial side is lined up with the positive x-axis. That's the important part here. When we work in this class and talking about angles, okay, and next class we'll learn about something else to kind of build off of this. We're pretty much always going to assume standard position, okay? So it's just nice to kind of have this built into our heads very early so that we can kind of work with it that way. So any angle we talk about from here on out, you can assume is going to be in standard position using this initial side and terminal side somewhere else in the plane. Okay. Moving on here. All right, well, that's great, but I haven't talked about actually measuring the angles. You might be wondering, where are the degrees, Mr. Who? Where are the degrees? Okay, well, we're getting there, so hey, hold on to your horses. Okay, we're still in the theoretical part. Okay, so when we talk about angles, you may not realize it, but there are also things as negative angles. Okay, now this is how we form our angles. So once I get into the examples after I discuss the measurements, we'll see these put into action. But essentially, when you're talking about a positive angle, for example, let's say 90 degrees, you would generate that 90-degree angle in the plane by counterclockwise rotation. Counterclockwise rotation. So, for example, I said 90 degrees, right? Let's go with 90 degrees over here. Here's my center. Here's my initial side. Okay, Remember, a 90-degree angle looks like kind of a nice boxy shape. So I'd be rotating this direction. Let me change my color and my thickness of the line. You'd be rotating in this direction. Okay, starting from your initial. And the side at 90 degrees would be something like this, right? Okay, so I counterclockwise rotated my terminal side to form my 90-degree angle, positive angle. Okay. Negative angles, as you may have guessed, these are going to be generated by clockwise rotation. So it's obviously the opposite. As we say, negative and opposite kind of have the same meaning. So in the same vein, let's say I want to make a negative 90-degree angle. Oh, I'm still black. That's all right. Well, again, you're going to start here. You're still starting there, but instead of rotating up, okay, we got to rotate down. We got to rotate clockwise. Okay. So let's go back to our big and fuzzy. Negative 90 degrees, something like this. Okay. Which, yeah, it's still a 90-degree angle. That angle didn't change, but it's rotating in the opposite direction, so we call it negative 90 degrees. Negative 90 degrees. All right, and a final bit of notation here, very simple notation, is that whenever you're talking about an angle, the variable we like to use, so we can kind of think of this as like your x or your y, is theta, okay, the Greek letter theta. That's kind of sloppy, but it looks kind of like an egg with a little dash through it. If you remember those Easter eggs that kind of pop open, that's kind of what I think about when I look at theta, so that can help you think about it that way. Okay. All right. Whew, now we got all the label stuff out. So now it's time to talk about the actual measurement unit as well as some math. Okay, so hold on to your horses. Things are about to get a little bit mathematical. All right, so we're back at it again, measuring angles. Now there is one measurement you definitely should know how to do. Okay, what unit that is you're familiar with. It is the degree, of course. We talk about degrees, that's the little degree symbol. And we know that 360 is like the whole circle and 180 is like the internal sum of the triangle, all that other good stuff. So that's all nice and good. Something very familiar we can use to help us learn this new unit we're going to talk about that's used primarily in trigonometry called the radian. Radian. Okay, so what is a radian? Okay, a radian is the length of an arc or the distance around the circumference of a circle. So there's a little visual down here that you can take a look at right here. Okay, so let's say here's your r, right, and here's the same r, the radius. This distance right here is the same as your r, so we call it 1 radian. Now this is a really important word to know, circumference here. Okay, when we talk about what makes up the radian, okay, we'll talk about this a little further, but the radius, okay, making up this one arc, okay, that is part of your circumference, which is the outer edge of the circle. So when we talk about the entire rotation of the circle, this will hopefully make a lot more sense. Okay, all right, so let's move on to talking about that. I'm going to do it on the same slide because I did actually make a graph for myself here. So I'm going to draw kind of a circle. Let's see if I can do it with a tool. Let's see if I can expertly draw my circle. Pretty good, pretty good. Okay, it's not exact. It's pretty good. Okay, so you may recall that I already said it as well, but the circle's degrees, if you kind of go all the way around, it's 360, right? So I'm going to use red for that. So you want to go all the way around, all the way around, all the way around, all the way around. You should be starting at 0. That's our standard position. Here's 90. Here's 180. Here's 270. And all the way around is 360 also. Okay, these are kind of the same, but they're slightly different. Okay, that's the degree side. In radians, okay, this is back to that circumference idea. If you recall the circumference formula from geometry, it is circumference equals 2 pi r. 2 pi r. Well, remember, we talked about how the radian represents the length of our radius. Okay. That would be this guy. So whenever we rotate all the way around with our radian measurements, okay, the measurements will start at 0 radians. Of course, if there's no angle, there's not going to be any measurement. There's going to be pi over 2. Pi, 3 pi over 2. And finally, we end up at 2 pi. So this 2 pi number is really important because it comes from our circumference formula, the 2 pi r. So the whole circle in radians is equivalent to 2 pi. All right, let's take a look at some angles in the plane. Okay, let's talk about formulating those from our own view. Okay, so if you want to measure these, follow along. You'll get to do them in the class later. Okay. But let's say you want to do a 240-degree angle. Well, first think about it. Okay, I'm going counterclockwise because it's positive, starting from here. Okay. And here's 90, right? Here's 180, so I know I've got to be in quadrant 3 somewhere. 270 is right here, which means my 240 is probably going to be around this area. Here's my 240-degree angle. Okay, so that seems pretty easy. Hopefully you were able to grasp that. Negative 150. Okay, so same thing here. I'm going to start from the center, standard position. This is negative, so I got to go clockwise. That's this direction. So when I think about negative 150, it's not quite 180, so I'm going to go out to 180 and go a little bit backwards and say, okay, it's about right here. Not perfect, but about right. And you'll notice when I did the negative angle, I put it in here instead of over here. That's because I'm indicating what direction I'm rotating. Remember? Okay. Finally, here's a radian one, pi over 2. Now, remember, this whole thing is 2 pi. Okay. So if you want to call this 2 pi, I know it's cutting off a little bit. Sorry about that. Okay. This whole thing is 2 pi. So this over here is 1 pi, and if you cut it all in half again, this is our pi over 2. So when I rotate to find my angle representation, I only go this way. And that's really bad. I shouldn't have done that. Oh, I can't do this. Close enough. There we go. It's the y-axis, essentially. Really bad at that. The other one weren't so bad, but that one for some reason was really troublesome. Okay, so hopefully with more practice you'll be able to see where these measures are. There's going to be plenty of practice in the Delta Math, mostly using degrees, but as we'll find out soon enough, the radians are also really nice to know. But as long as you know how to get between radians and degrees, that won't be a problem, hopefully. And that's what is up next. Conversion between the two measurements. Okay, so very, very simple. Whoops, went backwards one, sorry. Very, very simple. You need one thing. You need one piece of information. Very important. I would highlight this in your notes. It is that. Okay. One full rotation is 360 degrees. Okay, you already probably knew that. But it is also equal to 2 pi. It's also equal to 2 pi radians, which you can use grad, or you can just leave it as nothing. Usually we don't have a sign for it. You could call it r, and that's fine too, but we don't usually attach anything to it. So if you want to convert degrees to radians, we're going to be using this relationship, 360 degrees to 2 pi radians. You want to make it so that you want to translate all your degrees to radians. You simply have to multiply by pi over 180 degrees. Okay, that's the conversion to go into radians, okay, given that you start with a degree number. Okay, radians to degrees is the opposite. You're actually going to be multiplying by 180 degrees over pi radians. That way you can get your degrees back out. Okay, so very simple multiplications here. You can kind of think of that as this conversion if you're familiar with that, like from physics or science classes. Okay, so let's go ahead and take a look at our examples here. Okay, 45 degrees. Okay, it's a degree. Okay, so I'm going to take my 45 degrees, multiply it by pi over 180 degrees. Okay, and you'll notice that because degrees is in the top and in the bottom, you can cancel those units out. Okay, That's the entire point of this. And it's 45 over 1. Okay. And you can use your calculator to find this stuff, but this is going to end up being pi over 4 radians. Okay. One more from the degree side. Negative 150 degrees over 1 times pi over 180 degrees. Remember, this is not radians. This is just 1 to indicate that's what we're talking about degree-wise. And when you do this, I can simplify this a little bit. It's going to be negative 5 pi over 6. Okay. And very important here is we never round with pi. Usually pi is just treated as exact and we just keep it there. So try to avoid the temptation to simplify pi and round. Okay. All right, now to go from radians to degrees. Ready for this? I'll change my color. Okay, pi over 3. If I want to convert it back, I got to use 180 degrees over pi. Remember, this is in radians, and this is in radians, so they will cancel out nicely. But also, the pi's will cancel out too. So all you got to do is do 180 divided by 3, 60 degrees. Pretty solid. And, of course, the other example, negative 3 pi over 4. Again, I'm going to multiply by 180 over pi. Degrees, of course. My pi's cancel once more. Although this multiplication is a little harder. I think 180 is divisible by 4. It goes into 45, I think. And 45 times negative 3 is negative 135 degrees. Seem right. And there we have it. Alright, moving on. Last thing for today. Coterminal angles. These are angles that share the same initial and terminal sides. Okay. So these are called coterminal. For example, 30 and 390 are coterminal because they start and end at the same place. Okay, you'll notice that 390 is above 360, which means we actually have to bake in a whole rotation. Let's start with a 30 first. Here's my initial position. If I want to go 30 degrees, that's simply this rotation right here. Okay, right. Very small angle, doesn't go up to 60, doesn't even go up to 45, which would be like right here. So it's probably around something like this. Now, in a different color, I'm going to do 390s. Okay. Well, it's going to share the same initial side, right? They all share the same initial side. But I got to do one whole rotation. I got to do one whole rotation of 360, right? And then I have to add on another 30, okay, to get my coterminal angle. Okay. So the entire point of coterminal angles is that they look the same. They look the same. But they are different angle measures, just because they have to do a little more rotating to get there. Let's take a look at some examples here. Okay, so coterminal angles. We're going to find some coterminal angles. Okay, and this will be explained with another rule that I'm going to write up here before I end the video off. But let's say you want to find coterminal angles for 315. Well, first, you got to actually find the 315. This is a line tool, not the draw tool. So first things first, here's my initial side. 315 is almost a full rotation. Very close, but not quite all the way. Let's call this 315. Okay. Now, all your coterminal angles have to look like this. Okay, they have to have the same visual look. Okay. So when I look at this, there are a couple ways to get here. I could also say this, okay, which is a negative 45 degree angle. That would be a coterminal angle. Okay, I rotated backwards, but it looks the same, right? I could also go ahead and do this twice, right? Which would be something like, what is that, 675 degrees? That's pretty big. Okay, but these are both examples of coterminal angles. Okay, mostly helpful for putting your angles back into the range 0 to 360, so you don't have to rotate as much. And finally, this last one is using radians, okay, which we'll practice a lot with radians when we come around to it. Okay, but that's more for next time and not this time. But here's our first angle, 2 pi over 3. Remember, here's pi radians. Okay, 2 pi over 3 is not quite the same. It's probably something around here. Okay, so I need to find angles that look like that as well. Well, like I said from the last one, you can go backwards. That would be negative 4 pi over 3. If you're wondering how I'm getting that, I'm taking my 0. Okay. Well, actually, I'll explain it here later, because that's actually the rule. Okay. So that's our negative 4 pi over 3. And then here, I can do a double rotation and get 8 pi over 3. Now, you may be sitting there wondering, Mr. Hu, that looks like a bunch of magic and gobbledygook. Here's the rule. I'll type it in here for you. The rule is, okay, to find coterminal angles, simply add or subtract 360 degrees or add or subtract 2 pi radians. Okay. So that is the way to find it. If you notice here, the difference between 675 and 315 is 360. The difference between negative 45 and 315 is 360. It might be like negative 360, but same difference, really. Okay. Over here, 2 pi over 3. Well, it's not quite simply as simple as this, but if you add 6 pi over 3, which is the same as saying 2 pi but sticking a 3 under it and making a common denominator, that's 8 pi over 3. So I just added 2 pi there. Same if I subtracted it off, I get negative 4 pi over 3. And that's all there really is to it with the coterminal angles. Okay, we'll work on this more in class, so hopefully you were able to get a lot out of this video. I will see you in class.